Good evening, everyone, and happy Makar Sankranti to all. So, welcome back to third day of the online faculty development program on future. Oh, sorry for some technical glitch. So, welcome back to the third day of the online faculty development program on future innovations, energy, and sustainability. So, before moving ahead, I just want to make I want to note the participant a slight change about the resource person. Like the second technical session will be by Dr. Rajan sir, which has been rescheduled tomorrow as a technical session 1, and today's technical session 2 will be delivered by Dr. Mohan Lal Kole sir. So please have a note on that. And also participants, please make sure that keep yourself muted so that we can able to conduct the flow of the lecture nicely. So now we look forward to another insightful day of knowledge sharing and discourse. So we are pleased to have with us our resource person for this session, Dr. Mehebub sir from Damodar Valley Corporation, Kolkata. A warm welcome to you, sir. Sir is currently serving as manager at DVC Kolkata and has over 13 years of industrial experience in a central power utility environment. Sir has completed his BTech in electrical engineering from Jalpaiguri Government Engineering College, where he graduated as the departmental topper and later earned both his MTech with a gold medal and his PhD from National Institute of Technology, Durgapur. His industrial experience spans testing and commissioning of high tension and low tension switchgears, transformers, motors, CHP systems under EPC contracts, electrical operations, contract management, load dispatch, generation scheduling, and economic operation of the DVC grid. He is also a certified energy auditor under the Bureau of Energy Efficiency, Government of India. Sir has published 10 peer-reviewed journal papers, 15 book chapters, 3 books, and 25 conference papers, with research interest spanning smart grids, PMU applications, transmission loss allocation, energy storage technologies, and energy auditing. His engineering and research contributions have earned him numerous recognitions, including the POSCO Power System Award, IEI Young Engineer Award, CBIP Young Engineer Award, as well as multiple innovation awards within DVC for process and efficiency improvements. We are delighted to have you with us today, sir. Sir will be speaking on the topic digital innovations and grid optimization in modern power system. Sir, we request you to kindly take over the session. Thank you.
So very good evening, Professor Sarathi sir, and the FDP organizers for giving me this opportunity for knowledge sharing on the topic energy conservation and energy management in power industry, which is basically need for the future sustainability. Sir, before starting, just may I now the confirm that whether I am audible or not properly.
Audible, sir.
Okay. So this will be the content of overview. Such that energy efficiency and conservation in the power industries, how it is being achieved and why it is required, basically different barriers and challenges, and especially on the emphasis on the thermal power sectors, consisting of the different sections like boiler, pumping system, cooling water systems, and electrical system. The key parameters and the area where we can improve that energy efficiency. Different government initiatives and policies will be highlighted. Then it will be followed by two case studies of that energy conservation, which has been performed through energy audit. And being a power operator presently posted at a state load dispatch center, how the power is being dispatched to the different through different beneficiary, and how the grid management is being done. The first time charging, the electricity market operation, and with a special emphasis on the deviation settlement mechanism, which is very much required for grid stability. Now coming to the point that climate change, if we look at several climatic problems has been occurred in the last decades, like floods, cyclones, global warmings. But what are the root cause behind this? Basically, the global warming temperature. Temperature of the global world is rising, and this is being caused by basically the emission reduction. And the source of emission is from the power industry is the chunk major source. And among the power industry, especially the thermal power sector, because the 65% of total power is coming from the thermal power sector. Already we are talking about renewable, but still the thermal power plant has a major role in the total power for production segment. As a reference, it is to noted that 1 megawatt hour energy produces around 0.7 ton of CO2. This is as per CRC emission factor data. So looking on this and if we look into that share of industry in the carbon footprint, that 42% of the carbon or the emission is being caused by electricity sector or that electric power sector, and then it is being followed by the transport sector. Now in the electric sector, as told that it is basically from among electric sector, the thermal power plant sector is the major one. Now energy conservation is that basically it is that using that we have to use less energy to perform similar type of similar job or task. Likewise, that 1 kilowatt energy is basically produced from 2,400 kilocalorie heat of the coal. Thermal power plant, in thermal power plant, the power is being produced from the coal, and from this coal burning, that the emission is being caused to the environment. So if we increase the efficiency of the thermal power plants, then the energy is input to the thermal power. Basically, the coal input will be the less. So indirectly, it will have an impact on that carbon emission. As there is a proverb that if we save that 1 unit of energy at the consumer end, that is equivalent to that 2 times of capacity at this end, because that energy is being lost from that generator end to the consumer end. Now, the cost of, if we see that cost of fuel is the 80% of the total fuel cost of any thermal power plant, and if we there is a 8 to 10% of that energy is being consumed as a auxiliary power consumption, and due to this, that energy efficiency and energy conservation is a very crucial factor, because 8 to 10% of that produced energy is being consumed by its own auxiliaries. So that and here is the need is that, because that day by day we know that the fossil fuel source is limited, so this will be depleted on them, and there is an energy security issue, optimum plant utilization, and as well that global or mini effect, and the minimization of wastage, ultimately that cost reduction. Because if we don't improve that efficiency of the thermal power plant, then the tariff of the electricity which we are producing through generator, the tariff will be high, and this high tariff will be ultimately goes to the consumer. So that ultimate effect will be that the tariff cost will be high. So that to reduce that electricity cost, we must have to meet that energy conservation or efficiency, apart from that environmental sustainability viewpoint. As told that depleting fossil fuel, because fossil fuels is estimated, because it is estimated that after 114 years, there will not be no any coal reserve if it is being consumed at a current R/P ratio. And similarly, the gas reserve and oil reserves are also. So we have to think that we have to optimize that fuel input or that energy resources, along with that energy, renewable energy. We are talking about renewable energy, but still the thermal power plant has to serve as a base load to the grid. And to operate the thermal power plant, we need this fossil fuel. So this fossil fuel is consumption is to be minimized, and that can be achieved through energy efficiency or in energy conservation. So we have to think. Now, sector of consumption, because in industry sector has a very major portion, like 49% to the energy consumption. Next, it is being followed by transport sector. For an example, if we increase 1% in the efficiency, then it can save around 11 million ton per annum, which is worth of rupees 27,000 million, and it has also impact on the CO2 reduction of about 13.5 million ton per annum. And as told that the lower generation cost per kilowatt hour, increasing the efficiency will must have an impact on that cost of the generation per kilowatt hour. As the more efficient you need to work, the most economical power will be. Now that considering this point, a brief layout of thermal power plant is being given here, just to show the basic operation, how it is being worked. That the fuel mean basically coal is being transported into the boiler, and that here you utilizing that coal, that steam will be produced. High pressure steam. Then high pressure steam will drive this turbine, and this turbine is coupled with the electric generators, and the electricity is being produced. But during this process, so many auxiliary processes are there, like condensers, feed water pumps, makeup pump. There will be the cooling water to supply and to condense that water. Then after burning the coal, there will be some emission, and this emission will go to the chimney stack. This is the big operation, because this will be required for the drives for the next part. So many drives will be there, like different types of pumps, and these pumps will be driven by the electric motors, and these motors will consume the power during production of that electricity. And we have to reduce this power consumption by the different drives used in that thermal power plant, and that is the main objective. So the different parts of the thermal power plant is being divided here, like boiler system, tapo generator system, air and flue gas system, steam feed water condenser cycle, cooling water system, pumping system, and definitely electrical and lighting system will be there, and compressed air systems. One by one will be discussed. Like in boiler system, if we optimize the boiler operation, so there is some statistical data like 10% drop in excess air. That will be helpful to save 1% of the fuel in the furnace. So and it can have a capacity of an annual consumption of 3,000 liter of furnace oil, and installation of waste heat recovery system. If we can install a system that can recover the waste heat from that fuel from that furnace output, like for every 6 degrees centigrade rise in boiler feed water temperature through condenser heat, and there is 1% saving in the fuel. Similar fashion, that the water is being converted into the steam by the energy obtained from that coal, and that water is being poured through the boiler to the different tubes, and the tubes, and during that during over the times, the soot will be deposited in the tubes. So we have to reduce that scale and soot deposition, and that the parameter like scale formation of 1 millimeter thickness on the water side wall or tube will increase the fuel consumption by 5 to 8%. In the boiler system, some other parameters are like there, like improving insulation. We have to improve the insulation system to reduce that heat loss in the surface wall of the boiler, and like that heat loss from a furnace wall of 150 meter thick at 650 degrees centigrade, amounting to rupees 2650 kcal per meter square per hour, can be cut down to 850 kcal per meter square per hour. Now that we have to maintain the system pipe insulation, because that if that pipe insulation is not proper, that there will be heat loss. For an example, a bare steam pipe, 150 millimeter in diameter and 100 millimeter in length, carrying saturated steam at 8 kg per centimeter square, would waste 25 kcal of furnace oil in a year, and that is amounting to rupees 2.5 lakhs. Ensuring all insulated surfaces are cladded with aluminum, and we have to ensure that all flanges, valves, and the couplings. In air and flue gas systems, as told, that we have to optimize the excess air ratio, reduce the forced duct fan and induced duct fan loading, replacement of oversized forced duct fan and PF fan by using the ST variable frequency drive, because VFD drive has a very good opportunity to reduce energy consumption in the power industry. And for that, we have to do the proper study that whether that the drives each size the drive size is more than the requirement, and that is being done through energy audit, attending the air and flue gas leakage. If there is any leakage in the air and flue gas path, then it will increase the fan loading. Fan loading means ultimately it will increase the power consumption. In the cooling water system, we can improve the performance by proper monitoring that scale deposition, proper monitoring of pore airflow, and pore pump performance, the clogging of the spray nozzles. by installing automatic on-off switching of cooling tower fan and save up to 30% on electricity cost. Optimize the cooling water fan blade angle on a seasonal and load basis. For pumping system, in industry, during the design phase, the manufacturer gives the pump as per the requirement of the client. But after installation of pump, it has been sometimes it has been observed that the pumps are being oversized. Means that capacity is not required. So we have to replace that oversized pump because it will consume the more power than the requirement. Similarly, the throttling can also cause the wastage of power to the tune of 50 to 60%. Now coming to the electrical motor system, because in case of motors, as told, that sizing of the motor is very important. We have to design that motor rating as per the requirement, and we have to replace if the motor size is more than that as per requirement. Use of an energy efficient motor. Optimizing the voltage level of the distribution transformer used in that thermal power plant, and use of soft starter in case of induction motor because it avoids the mechanical stress on the different drives like chain, belt, gear, conveyor, and it will also extend the motor life. Motor life will be extended. For illumination and lighting systems, we have to use that CFL or a LED lamp in place of GLS lamp. We have to clean the lamps and fix regularly, and it will improve also that illumination performance. Also, that sodium vapor lamps for a large area lighting, and we can replace the mercury vapor lamp with that sodium vapor lamp, and there is a potential of saving of up to 40%. In case of compressed air system, compressed air is very costly, and this compressed air is required in any power industry for two purposes: to operate the pneumatic valves or actuator, and another purpose is the cleaning. And for cleaning purpose, basically surface air compressor is required, and to operate the pneumatic valve, that instrument air compressor is required. So in that case, specific power consumption is to be carefully examined. And as we told, that compressed air is very costly because only 5% of electrical energy are converted to useful energy through compressed air. So wastage of compressed air is to be minimized, and we have to increase the inlet air temperature by, and if we increase the inlet air temperature by 3 degrees centigrade, and that will increase the power consumption by 1%. So for motor will be that reduction of the inlet temperature of that at inlet, and it should be examined whether air at lower pressure can be used in the process, because if discharge pressure of the compressor is higher than requirement, then that high pressure will be unnecessary wastage. So we have to design that discharge pressure or that output pressure of the compressor, and definitely the leakage from the compressed air must be avoided, because the leakage from a half-inch diameter hole from a compressed air line or working at a pressure of 70 parts per square can drain almost 2,500 rupees per day. Now, these are the various parameters as told that in case of thermal power plant, what we have to observe to maintain the efficiency and energy utilization at an optimal level. But in spite of this, there are so many barriers because generally we focus on the plant load factor. Means the how much time or how much hour the plant is being generated, and every utility is trying to maximize the plant load factor instead of efficient generation. We have to maintain 85% or 90% plant load factor, and degradation of equipment resulting in loss of the capacity. Also, there is a financial constraint lead to inadequate maintenance, and there is an inhibition to adapt new process and technology. Right. This is a very vital one because some new technology has come, but that management or any organization basically don't adopt that technology wholeheartedly at the first time. There are so many complex procedures to adopt the new technology. So these factors are basically become a barrier for efficiency improvement in the thermal power plant. Now, in case of miter, same thing. How the different parameters will be impacting that heat rate of the thermal power plant, and that amount of saving will be how much based on the different parameters like main steam temperature, main steam pressure, water heat temperature. These are the different parameters used in the thermal power plant, and this is the reference value of these parameters. And if there is a deviation of this parameter from the reference value, like this is actual value 535 degrees centigrade, and the reference is that 537 degrees centigrade for main steam temperature. So there is a deviation of 2 degrees centigrade, and this 2 degrees centigrade deviation will cause a heat rate. Heat rate means how much heat is required to produce 1 kilowatt of energy. Means we are losing 1.3 kilocalorie in energy for producing 1 kilowatt of energy. Similarly, for all parameters, the heat rate are given here. So from this, we can get an idea that how the different parameters will be impacted. Now, coming to that same thing, for deviation from the design value, what will be the impact in the monetary value actually? If there is a variation of load of 1 megawatt, then the heat rate deviation will be 0.77 kcal per kilowatt hour. And that will result in saving of rupees 2,700 per day. And here we have considered that GCP value or the gross calorific value of the coal is 3,700 kcal per kilogram. And plant load factor PLF is considered at 80%. This is a typical example, but from this we can get an idea that how these parameters, deviation of that deviation from standard parameters is not allowed. If we deviate from standard parameters, then there will be a monetary loss or monetary saving as per that deviation from actual. So ultimately, during operation of a power plant or an industry, we must have to look that we have to maintain the parameters, the main parameters of the different processes as close as to the design value. So various types of different equipments in any power industries like the pump, fan, compressors, conveyors, mill, crushers, crane, hoist, traction, etc. will be there, and all these drives will be operated by electric motors. And basically, these motors in the power industry are three-phase induction motor because of the cheapness, robust construction, and satisfactory performance. Mostly three-phase induction motors are used. So during the selection of motor and proper selection of rating and design, they will result in a minimum cost and specified motor life expectancy also. The motor size will be very much important. And how that energy conservation opportunity can be found in any power industry. For that, we have to do that energy audit. And this energy audit has several steps. Like we have to first we have to design, then retrofit or site modification. And that is a different steps. Like this, first we have to do the field survey. During the field survey, we have to calculate the data and different measurement for various parameters of that equipment. Then that collected data will be analyzed, and from this data analysis, we have to assess the equipment performance, how the equipment is actually presently. And if there is any chance or if there is any possibility of improvement in performance, and that is to be assessed by through cost benefit and analysis. And if we see or observe that the performance improvement is possible through process improvement, then that is to be implemented. After implemented, then again is to be rechecked and revalidated that whether actually performance improvement has been occurred or not. So these are the basically steps: field survey, data collection, data analysis, performance assessment, cost benefit analysis, then implementation. After that, recheck. And during an energy audit, several types of instruments are being used for measuring and collecting different types of data. Like in case of motors, we have to collect that voltage, power factors, that how much ampere is being taken, how much power is being consumed. There are so many mechanical equipment, pumps, so we have to measure the pump flow, and air flow also. And that is being to be done by the digital anemometer, hygrometer, power analyzer, portable clamp multimeter, ultrasonic thermometer is required for measuring flow of the water for the various pump. The digital temperature indicator is required for measuring temperature of the flue gas inlet, outlet, or that boiler temperature also, and the different parts of turbine, condenser, etc. Digital tachometer is required for measuring the speed of the motor. So many equipments are required for measuring the different parameters. A case study is being shown here that and that energy audit is being conducted at the Damodar Valley Corporation Raghunathpur Thermal Power Station. And first case study is related with an energy saving opportunity in compressor. In case of, as told, that compressor, there are two types of compressor. First is instrument air compressor, and second is surface air compressor. Instrument air compressor is required to operate the pneumatic valves. As surface air compressor is required for basically cleaning purpose. And during an energy audit, that if the FAD has been conducted, actual pre-delivery test and specific power consumption of each compressor has been done. After completing that data collection, that the different parameters are being shown here, like the pressure, set loading pressure, set unloading pressure, total volume, FAD, and here that two parameters is important, that set pressure for service compressor 1 and service compressor 2 was 5.8 kg per centimeter square, and here that unloading pressure was 7.2 kg per centimeter square. In that case, that service air compressor, the discharge pressure was high actually, and this high discharge pressure was causing that energy loss, which is not expected. Then after audit, what we have found that there is a high discharge pressure. High discharge pressure means 7.2 kg per centimeter square, and so there is a good opportunity that if we can reduce that discharge pressure from 7.2 kg to at least 6.7 kg, then that will serve the purpose, because our set pressure was inlet pressure was 5.8 kg per centimeter square. So gradually the pressure setting has been reduced, and with a step size of 0.1 kg per centimeter square. And there is a thumb rule that 1 kg per centimeter square reduction in pressure will result in 8 to 10% of saving in the power. So after process modification, that discharge pressure has been modified from 7.2 kg to 6.7 kg. Here, modified the discharge pressure is from 7.2 kg per centimeter square to 6.7 kg per centimeter square. And during this process modification, we found that the power saving is around 50,000 kilowatt, 50,000 approximately 50,000 for both compressors per year. And if we only just consider that cost of generation 2.42, so there will be a monetary saving of around 12 lakh. And for that we need no investment. Just we have to change that pressure setting and the process improvement. Here only the cost of generation is considered. We have not considered that price of power selling, because the random cost will be generation cost from the power plant will be lower than that power selling cost. We basically generate power at rupees 2.555 to 3 rupees. Now that in the second case study is that in case of condensate extraction pump, in case of condensate extraction pump, we have 3 condensate extraction pumps. 2 pumps are acting at a time, and third pump is being kept at a standby. And this is the design specification of that condensate extraction pump. The power rating is 1250 kilowatt. 1250 kilowatt means 1.25 megawatt. So this is a very huge rating. And this 1.25 megawatt, from this, if we can save 2 to 3%, that is also huge saving. So, but how this is being identified that this pump is being taking more power as per than that requirement. Here we have calculated that specific energy consumption of the both pump, and we have observed that CP there is a recirculation valve, and that recirculation valve was kept open at both the units for maintaining the low discharge pressure at CEP. Because the discharge pressure of CEP condensate extraction pump was found 28 kg per centimeter square for unit 1, and for second unit the discharge pressure was 23 kg to 24 kg. But the diameter pressure was approximately 9 to 10 kg. So this this huge discharge pressure is not actually required to meet that deaerator pressure, because we have to throw the water from CEP to deaerator. So there is a huge gap actually. And during the recirculation valve, that 13 loss was occurred. So that can be eliminated, and this is a very high rating motor. So in that case, if we can install the VFD, then that will serve our purpose, and we can save a very good amount of power. Now, the operating principle of VFD, as you know, there are so many speed control mechanisms, like outlet damper control mechanism, inlet guide vane control, or hydraulic coupling control. So VFD drive has a very high efficiency compared to that other speed control mechanism. And for that, the choice of VFD is justified. And if we look into that current drawn by the VFD, current drawn by the VFD is smooth in nature. Also, the amount of current drawn is lower side, and there is no fluctuation. But in case of under starting current, there will be fluctuation. So the drive's performance or the mechanical stress on the drives will be more. And that is why the VFD is a very popular choice in any power industry. The specific power consumption for the two VFD, two CCP on B and two QATB has been conducted, and that result is being shown here. And from it, as told that here basically specific power consumption is to be reduced. And that is to be done. That has to be done by reducing the discharge pressure. So here the present power consumption was around 1075 and 11551 for CEP 1B and 2B respectively. And that is expected saving of around 20%. After calculating this and considering the generation cost 2.4 around, that monetary saving will be around 0.144. And if we consider the investment, the payback period will be around 2 years, 26 months or 24 months. That is around 2 years. So this project is also feasible, and that's why after installation by the manufacturer, the many drives in the industry is being replaced by the variable frequency drives. After assessing this cost benefit and analysis, so now the policy initiatives what the government is taking for improving the efficiency in the power sector. So different policy has been framed up by the government. Among these, that policy of the National Action Plan on Climate Change, promotion of clean and clean technology, and Energy Conservation Act 2001. This is the most prominent one. And this act mandate that we have to conduct that energy audit in any power industry which comes under the designated consumer. Means that power in the industry which has a high energy consumption, and that industry is to be conducted that energy audit every year. The Electricity Act 2003, National Electricity Policy 2005, and that adoption of supercritical technology for 660 megawatt or 800 megawatt unit for ultra mega project. Because of that, these units have 660 megawatt or 800 megawatt units have very high efficiency compared to that 500 megawatt or 250 megawatt in grid. So presently, government is not allowing any 250 megawatt in grid. They are only focusing on the supercritical technology. And increase the emphasis on environmental consideration. Indian Electricity Grid Code, Indian Electricity Grid Code 2023, IEGC, because this grid code, grid code has so many sections and so many policy formulations to improve the grid performance. How the different, how the energy transaction will be there, how new connection will be connected. This IGC code will serve this purpose. There is a renewable purchase of obligation, RPO. RPO for every utility, for every power generating company, certain amount of power is to be purchased from the renewable sources. These are the policy, and that barriers. As told that plant load factor, we basically emphasize on that plant load factor, the degradation of the equipment over the years, and there is a financial constant, inadequate monitoring system for the parameters, and lastly that inefficient to adopt new process and technologies. Now the Energy Conservation Act, as told that the Energy Conservation Act, this act has been passed in the Parliament in 2001, and this is the stepping stone for that for promoting energy conservation in any industry. And this act mandated that energy audit for energy intensive industries by accredited energy auditor, and this act also developed different types of norms and benchmarks for the energy intensive industry. And this is basically Bureau of Energy Efficiency, BE was created for the implementing agency, and for this act. But how this act will be, the different sections will be executed, the BE will properly monitor that. And there will be an energy management center under the Ministry of Power, merged with the BE. And under the Energy Conservation Act, it has been told that energy certified energy managers and auditors will do that in energy audit in any energy intensive industries. And this is required to monitor the power consumption. Whether the power consumption in industry is up to the benchmark, or the power consumption is beyond the benchmark, and if there is any deviation of the power consumption, then what are the improvement? What are the basically the possible opportunities of the explore? We have to explore the opportunity that in which case we can improve that that energy efficiency, and we can save that energy. And that is the main objective of that energy audit. Now, National Mission for Enhanced Energy Efficiency. This is also a mission of Bureau of Energy Efficiency. In that mission, we has to prepare the standard and labels for equipment. As we know, for different types of equipment, like for domestic appliance also, air conditioner, fridge, the standard and labeling, we know that 5-star rating, 3-star rating, 4-star rating, and that standard and labeling is being done by the Bureau of Energy Efficiency. And another work is that developing list of designated consumers, because the designated consumers, these designated consumers are to be these designated consumers are mandated to conduct that energy audit. So who will be the designated consumer? And these designated consumers are given here that there are 15 energy intensive industries. These industries basically they consume very huge amount of power. So they are known as designated consumer, and these designated consumers have to appoint designate an energy manager or energy auditors, and this energy manager and auditor will conduct that energy audit, and after an energy audit, the implementation of techno-economic viable recommendation is to be done. And the compliance with the norms specified energy consumption, and the submit that report. There are different designated consumers, are few designated consumers are given here, like as told thermal power station, fertilizer industry, cement industry, iron and steel industry, aluminum industry, railway industry, textile industry, pulp and paper industry. Here only basically I focused on the thermal power stations because I worked on thermal power. But apart from this, that these industries are also comes under the purview of designated consumer because they are energy intensive industries. So energy audit is to be conducted for all these designated consumer. Now, certification of energy manager and auditors is being done through national exam, and this national exam is being conducted by National Productivity Council. There are so many exams has been conducted, and more than 15,000 candidates have appeared. 7,000 have already qualified, and as told already that in Energy Conservation Act mandates each designated consumer has to employ an energy manager, and periodic energy audit is to be conducted by designated consumers. Now this another scheme under Energy Conservation Act is that performance achieve and trade. That is known as PAC. Means that name itself suggests perform, achieve and trade. The industry has to perform and achieve, and after achieve they can trade. This is simply known as PAC. How it is being worked basically this is a market driven mechanism. Here some baseline target of energy saving will be given to any industry, and that industry will do that. If suppose here for example is given here two scenarios given, scenario 1 and scenario 2. The industry will be given the target of specific energy consumption. Means that you can consume that this much of energy. And for scenario 1 or for industry 1, this industry 1 or industry 2 suppose, and if industry 1 consume that this much of energy, so ultimate this much of energy is being saved by industry 1, based on this target. So this amount will be issued as a ESAT, means energy saving certificates. This amount will be issued as a energy saving certificate to industry 1. In a similar fashion for industry 2, this industry for this industry, that energy consumption is up to this level. Means the energy consumption level is higher than that target. So that this industry 2, that energy saving certificate is to be purchased because they have consumed the more energy than that targeted energy. So this amount is to be purchased, and from whom you will purchase, you or she will purchase, you will purchase from the industry one. Industry two will purchase from industry one. So there will be so many industry. This basically performance achieve and trade mechanism. The certificate will be issued, and this certificate will be traded in the market. In the market, and this is required. This is basically required to promote that energy efficiency in that industry, because until and unless there will be a compulsion, the industry will not do. So to promote that energy efficiency, the pack cycle has come, and the pack cycle has already crossed the different cycle. Pack cycle 1, 2, 3, 4. This basic objective is that through pack cycle, industry can save that energy, and that certificate will be issued, and this certificate can be traded in the market. Simple how it is being traded in the market is being given here. Here basically that auction timing will be 13 hours to 15 hours, and the one certificate is equivalent to 1 million ton of oil equivalent. And this is basically payout will be T plus 1 day, means 13 plus 1 day. That trading day, after the trading day, the payout will be there. How it will be work that in the market is that different timeline is being given, like market participants submit their bid, and this is being traded in the PXIL, means Power Exchange India Limited. 13 hours, then 15 hours they will submit the bid. Then after that, sale quantum will be registered. Then that is certificate registered to confirm the power, and there will be two concepts like market clearing price and MCP, and based on the market clearing price and market clearing volume, that certificate will be traded in the market, and it will be completed by 17 now there is generator connectivity. Connectivity and fast time charging for procedure for energy and power management. If we look at energy transition since last few decades, that huge changes, like solar energy growth is around 2,700% from 2015 to 2025%. A huge energy transition has been occurred since last two decades. So many we have achieved that around renewable capacity to total installed capacity 490 gigawatt, and non-fossil fuel based generation we have already achieved 246 gigawatt, and our target is that up to March 2030 is that 500 gigawatt. So looking into that energy transition, a huge rate renewable penetration is there. So the market has changes also a lot. The different mechanism, different trading mechanism has also come. Like and in that context, as the renewable energy generator or the grid integration process, how the renewable generators integration is being taken place. There are so many steps. Like first that particular entity is to apply that for connectivity. Then the in principle approval will be there. Then the connection agreement with central transmission utility. Then the registration will be done at RLDC, Regional Load Dispatch Center. First time charging will be there. Then after that trial run, the COD will be declared. COD means commercial operation declaration. The detail of the fast charging procedure is already available in Bid India website. The link is given here. The step for the registration is being given here. Like they have to give the detail in the registration portal. Then the details will be then upload the document. diffuse and submit. After the confirmation, the registration will be done at regional load dispatch center. The different key for user. Different types of user, different key will be there. Like HPX, IX, and PXIL, the field with 30 lakhs, the distribution license, the generating station for different quantum. For different quantum of the generators, the field will be different. This is just data for different key. Now the first time charging purpose procedure that basically it consists of three steps: intimation and technical detail submission. And under this step, the technical parameters of that entity is to be given, and there are so many forms are there in the website, and annexure A, from starting to annexure A1, A2, A3 up to A6, then B1 to B5, C1 to C4. First is the intimation and technical detail submission. Then that and that is to be done 6 months prior, at least 6 months prior. Then after that, that will be reviewed by RLDC, and that submitted to 10 days prior. And undertaking and trial and notice is to be done 7 days prior. And in that case, the contract code is to be filled up. Then after then trial run is to be conducted as per IGC 2023. Then submission of C1 C2 form and his issue of trial run certificate within 3 days. This is the procedure for first time charging of any new element in that in that grid actually. That the concerning the different time frames, the different steps are also being given here. Like I told that first the user registration is to be done. After user registration, then the submission of form 2, then the submission of B1 to B5, and then the submission of format 4. Then after this step, the date is to be proposed. Proposed date for energization of power system element. And after this step, trial and phase start. Trial and phase start here. Here, completion of trial and operation with submission of form C1 to C4. Then after trial and the clarification. If there is any after trial run, that RLDC will issue that trial run certificate in case of no objection is raised by beneficiary in 2 working days. But if there is no objection, then the clarification is to be sought by RLDC, and that reply to this clarification is to be done within 3 working days. And after that, RLDC will decide that final certificate will be given or not. So this is a big idea, and with the different time frame, how that first time charging will be conducted for any power system element. Now the dual of power, the dual of starter power and infant power of injection. Infant power means when we connect any generator into the grid, so that few equipment, auxiliary equipment will take some power, and after connecting the power to the grid, that power will be injected to the grid, and that power is known as the infant power. And this income power will be guided by DSM regulation, deviation settlement mechanism regulation, because the power flow through the grid is very complex. Whenever any utilities or any beneficiary or consumer utilities are basically pushing power in the grid, and the consumer is taking power. So the utilities cannot push power without without any limitation, because there is some regulation, and that pushing power or transaction of power through the grid is being guided by deviation settlement mechanism. So that will be discussed later on. Now, if we connect the generator into the grid, then what will be the procedure? There are two types of generators. The generator may be thermal power generators, or that there may be that hydel power generator. So for thermal power generators, we have to conduct 72 hours trial run. And 72 hours trial run we have to conduct at a maximum continuous rating, means in NCR. The rating we have to, if the generator rating is 500 megawatts, so we have to trial run of that unit for 72 hours at a 500 megawatt, and maximum 4 hours. And during that time, maximum 4 hours of interruption can be possible. And if the interruption greater than 4 hours, during the 72 hours, more than 4 hours interruption is not permissible. If interruption more than 4 hours, then the trial run is to be repeated again. These are the regulation, and directed capacity of any generators cannot be more than 95% of that total capacity. Now, that continuous for hydropower generators, that we have to conduct that trial run for 12 hours. For thermal power plant, it was 72 hours. But for hydropower generators, the continuous operation required for 12 hours. And here is also maximum 4 hours short interruption or load reduction is possible. But interruption greater than 4 hours required repeated trial run. And here the derated capacity will be cannot be more than 90% of that total capacity of that generator. So after trial run, the several testing of that equipment is to be done, like the reactive power capability, assessment of reactive power capability, whether that equipment or whether the generator is sufficient or the capable to provide the reactive power support as per the reactive power capability curve. Because if it is not capable to provide the reactive power support, then the grid will be affected. Then periodic testing after every 5 years is to be required. And also the different types of model validation and verification test, like excitation system model and turbine governing model is also to be conducted. And testing of governance performance and AGC is also to be conducted. And all these things comes under the purview of IGGTC regulation 22. Regulation 22 of IGC 2023. And if the successful trial run is completed, then that commercial operation or COD is being declared, and the COD is being declared. COD will be declared for D plus 2 day. Means that if trial run is completed 2 day, then that D plus 2 will be the actual commercial operation day. Now the basic regulatory bodies for the power sector is that mainly is the Ministry of Power, and under that CES, Central Electricity Authority, and CRC is there, Central Electricity Regulatory Commission is there, and BE is there for basically promoting energy efficiency. Last part is that in energy management through deviation settlement mechanism. As told, the grid management is to be grid stability is to be ensured, because the renewable penetration is increasing, and this renewable is causing that intermittency in that source actually, And basically it is causing that because people have no inertia, as, as as we know. So it has it has imposing on the grid that frequency is instability. So nowadays we observe the frequency variation in the grid parameter. And depending on the frequency, how that grid will be stable. So for that, the DSM regulation comes. And in that context, basically two types of market is there. One is the day-ahead market, that is known as DAM, and second is the RTM market, means real-time market. And interesting fact is that electricity price is varying depending on that frequency. Apart from the domestic consumer, as a domestic consumer, we are taking power from DISCOM at a fixed price, like 7 or 6 rupees. But from generator concept, when generator is pushing power into the grid, and the generator is selling power to the consumer, the generator will not get that tariff at a fixed rate. There will be two parts. One, there will be fixed cost and variable cost. That variable cost will be depending on that frequency actually, and will be guided by DSM. And DSM, how it will basically work? As told, the two types of market is there, DAM and RTM. So objective of DSM is basically is do not deviate, because grid user do not deviate from and adhere to the rule of coil and injection. In the market, every generator or every utility has to comply their rule. Suppose the generator already give that they commit that they will provide schedule of 500 megawatt in the next 5 blocks. So in the next 5 blocks, they must have to provide the 500 schedule or as close as 500 schedule. The deviation may be there, but the deviation, depending on the deviation, the rate will be changed. The more will be deviation, the rate will be the rate or penalty will be there according to the DSM guideline. So basically, that example it will be clear after giving an example. Like in earlier case, basically that rate was that highest of the DAM and RTM. But present in DSM the regulation, that rate of charge means rate of the electricity price will be maximum of weightage average of RTM or DAM. Maximum of weightage average of RTM and DAM. And the frequency, the most important part is that interesting part, that based on the frequency, the rate will be changed in a very peculiar manner. And that will be shown in the latter stage. It basically depends on the slope of the graph actually. Like from DSM curve here, from a two things is there. The deviation, two terms is the deviation. Deviation means suppose any utility has committed that they will inject power of 500 megawatt for the next block. Means now it is presently it is 7:20 p.m. 7:20 means from 7:30 to 7:45. They will push 500 megawatt. But due to some problem in the unit, they push 400 megawatt. Then, and if in case of peak period means evening period, low generation will cause the instability to the grid. So that particular utility will be penalized. Now, how they will be penalized? That will be guided by this graph actually. This is to be looked into very carefully actually. Now consider just see this frequency range. For frequency range 49.85 to 49.9. 39.85 to 49.9. The green curve is basically for receivable price. Means this price will be received by utility, and the red curve will denote the utility is being penalized because they are payable due to overdwell. Means there will be generation shortage, and here is the underdwell. But how the frequency will come into the picture? In case of low frequency, very low frequency, 49.85 to 49.89. In that case, if any utilities inject or underdwell the power, so they will be provided the incentive, like 100% of price. After that frequency band, 49.9 to 50 hertz, 49.9 to 50 hertz, that there is slope of 1%. So and depending on this slope, the 90% price, 90% of the rate will be provided. After that frequency, 50.05, only 50% rate will be given. So see that if the frequency is increasing, and in that case, that underdwell is encouraged. In a similar fashion, in case of low frequency, if there is overdwell, low frequency the 150%, there will be 150% penalty, 150% of the reward. And similarly, for that next frequency range, 49.9 hertz to 50 hertz, if there is a shortfall means overdwell, the frequency is already low. But in that low frequency range, the generator is shortfall. Generation is shortfall. So that the 100% they will be penalized with the rate of 100%. And for the high frequency range, because the frequency is high, so the rate will decrease. So for lower frequency range, the higher penalty rate for lower injection. And for higher frequency side, the rate of penalty is reduced from 100% to 25% to 50% based on the frequency rate. And first block, this is for first block. Block 1, and deviation up to 10% or 100 megawatt. There is 3 block actually: block 1, block 2, and block 3. For block 1, it is considered up to 10% of deviation. Suppose the schedule is that committed power is 2000 megawatt. So up to 10% can only be considered, means 100 megawatt or 100 megawatt. 200 megawatt will not be considered. And for that next 100 megawatt, that next block will be considered. That is deviation from 10% to up to 15% or 200 megawatt. So here the frequency curve is little bit different. Here also that main concept is same, that during low frequency under generation will be avoided, because under generation will further cause the grid instability. So they will be penalized by a rate of 150% of that rate. For the low frequency range, 49.85 to 49.99. And beyond that, it will be 100% and 75% based on that frequency. Similarly, for low frequency, now for low frequency, during injection by generator, because already frequency is low and the generator is injecting power, so definitely the generator is trying to stabilize the grid. So they have to be incentivized, and so they will they will pay that 80% of the cost. And this tax will be received by the generator. And for the frequency from 50 to 50.004, that they will also receive the price, but that amount will be less, 50%, because already frequency is on the higher side. So higher the frequency, that rate, the rate of receivable price is also goes down. This is basically vice versa. Means during lower frequency, we have to basically increase the generation. That is the main objective. And during a higher frequency, we have to minimize. We have to minimize the generation. That is our main objective. And this is for block 2. Block 2 means 10% to up to 15% or 200 megawatt. As told that for example, the committed power is suppose 300 megawatt, 3000 megawatt. So 3000 megawatt, 10% will be that 300. But for this block, only 200 megawatt will be considered. First 100 block will be considered for first case, and for second case it will be considered for the block 2, and next 100 megawatt will be considered for this block 3. It will be block 3. Here the path will be little bit different. Means the slope will be different. Here that is the penalty will be 200%. 200% for low frequency region, 49.85 to 49.99. Because so objective is that means higher penalty. Higher penalty is for more deviation greater than 15% of 200 megawatt. That means basically that DSM regulation says that we have to minimize that deviation. Lower the deviation, better will be the grid stability. So we have to keep the deviation lower. If we deviate more than schedule, then the penalty rate will be more. Penalty rate will be 200%. Just see here. From block 1 penalty was 150%, but the frequency band was low. Here penalty 150%, but the frequency band is also high. And in third block, see that penalty is 200%. So it is quite high. So after imposing this DSM regulation, the utilities will try to minimize the deviation from their schedule, so that grid stability will be improved, and the grid frequency variation will be minimized. And from this concept, a case study is given here from a practical data of that data is taken from 12 January 2026. Like in the day, 24 hours, basically the power is being scheduled 15 minutes in interval. So for 1 hour, there is a four block. So for 24 hours, there will be 96 block. Just for concept that 18 time block is given here, and few data point will be discussed. Here for time block 1, the DVC schedule was that DVC schedule was 196 megawatt. Simply, and 196 megawatt DVC deviate deviation is 27.6 megawatt hour. And in that block, frequency was 50.03. Increase frequency was high. And in that high frequency, that injection, plus mean injection and minus mean shortage, means this power is being injected into the grid. So frequency was high, but at the high frequency, that more power than the CD was injected, so penalty will be there, and a loss of around 40,000 has been occurred, and this loss has been calculated based on the charge as told RTM rate and dam rate, means the real time market and day ahead market rate. For block 6, if you see here is frequency 50 hertz, but here deviation is minus 50, means that the generation was lower than that actual. So that in that block, the utility was helping the grid. Utility was helping the grid to maintain the frequency for negative injection. So a gain of 16,000 means the utility will be paid to 16,000, paid by an amount 16,000. In the last block also you see 50.01 hertz. 50.01 hertz. There is negative deviation. High frequency negative means there is shortage of generation. Means also the utility is helping the grid to maintain the stability. So a gain or utility will be incentivized by this amount. Sir, after 5 minutes, 5 minutes or 2 minutes. Just from this graph, you can see this year tabular form for 18 block, and now this is for the whole day, from block 1 to block 96. That is being here. As soon as that for block 1, 2, 3, this is negative, means the penalty has been imposed, and this is positive. Block 4, as told that is for block 3. The block 1, the loss. Block 1 to 3 is negative, and block 4 is positive. Positive. Yeah. So in a similar fashion, all these for all these blocks, that gain or loss of the utility will be shown here. And this is being calculated by from this actually graph. Here if we see that as told the dam rate, normal charge rate, depending on the frequency, the charge rate is with variation. This one, that charge rate is being varied by this. So there is a huge variation of the electricity price. It goes suddenly 10 rupees here, 9 rupees here. This is almost 10 rupees. And sometimes there is also 4.5 rupees, 6 rupees, depending on that frequency at that block actually. And calculation is being done accordingly. So based on this, then when research opportunities are that we have to, there will be a generation and demand deviation minimization, accurate load forecasting, exploring the new market mechanisms, grid frequency stabilities with virtual inertias, exploring the energy efficiency improvement area in power industries. These are the possible research areas for this topic actually. Now the conclusion is that main is that there is a considerable potential of reducing energy consumption and by adopting energy efficiency measures in thermal power plant station. And energy audit is very much essential for exploring that energy efficiency improvement and to identify the gap and energy saving opportunities also. Also, that grid stability can be improved through compliance of DSM regulations, and the rewards and penalty imposed depending on the grid frequency. And better energy management will give to sustainable, reliable, and stable power networks. Now, thank you very much.
Thank you, sir, for such an insightful and practical oriented session. Now we will take few questions from the participants. So participants, please move ahead with your questionnaire. Be quick.
Okay, thank you, Mehebub, for this wonderful lecture. Hello.
Okay, sir. Thank you, sir. Any query, sir?
Thank you. It's a great lecture. It's a wonderful lecture. I was listening to this lecture. It's a very insightful lecture. We are really privileged to have you.
Actually, lot of things are there, but time is very limited.
Yeah, that's the thing. Okay, Mehebub, thank you for your presentation. Good lecture.
Okay, so I would like to request everyone to please switch on the camera. We have to take the screenshot. Sir, if you can, yeah, thank you, sir. Okay, thank you, everyone. And I would like to thank again, sir, for giving his valuable time. Thank you, sir.
Okay, thank you all.
Thank you.
Thank you, sir.
Now, moving ahead, let's start the technical session. Okay, sir. Okay, sir, sure.